Here we have graphed some points. We have points E and J and A and B. Our question is, how can we find the distance between point E and point J? Looking at these points, how can we find the distance between the two of them? Well, if you think about it, maybe the easiest way would be simply to count the number of spaces between the two. 1, 2, 3, 4, 5, 6, 7, 8. So if we count along our number line, we move 8 spaces. So the distance between point E and point J is 8. Now, let's take a step back and see if we can look at the distance between points A and B. We can count these, again, 1, 2, 3, 4, and we know that our distance between A and B is 4. However, we don't always see these plotted on a graph like this. Sometimes we see individual coordinates. Here we have the coordinates of points A and B. A is at 1, 2 on the x-coordinate and 1, 2, 3, 4, 5. So 2, 5. And B is at 1, 2 on the x-coordinate and 1 on the y-coordinate, giving us points 2, 5 for A and 2, 1 for B. Now, if we want to find the distance and all we have is the coordinates, we can't just count, then we have a special way, 2 different ways, of finding the distance between those points. If they are in different quadrants, then we have one way to work the problem. Which of these 2 points are in, or which of these pairs of points is in 2 different quadrants? Well, E and J are in 2 different quadrants. A and B are both in quadrant 1. If we're going to take and find the distance between 2 points that are in 2 different quadrants, we have a special rule here. We will add the absolute value of the coordinates that are not the same. So looking over here, here are my coordinates for E and J. E is -2, -2, 1, 2, 3, 4, -2, 4. And J is +6 for our x-coordinate along the x-axis, and 1, 2, 3, 4 along the y-axis, so 6, 4. Which coordinates change? Is it the x-coordinates that change or the y-coordinates that change? The x-coordinates change. So we're going to add the absolute value of the coordinates that are not the same. So we're going to add the absolute value of these guys. Quickly, what is the absolute value of -2? It's 2 spaces away from the number line, so its absolute value is 2. And the absolute value of 6 is 6. We'll add those 2 together, and we'll get 8, which, if you remember when we counted, 1, 2, 3, 4, 5, 6, 7, 8 is the distance between those 2 points. If, however, the 2 points are in the same coordinate, if they're in the same quadrant rather, not coordinate, we will subtract the absolute value of the smaller coordinate from the larger coordinate. So we look over here at A and B, and we see that the coordinates that don't change are right over here, 5 and 1. And we will subtract the absolute value of the smaller coordinate, this is the smaller one, from the larger coordinate. So the absolute value of 5 is 5, and the absolute value of 1 is 1. So we're going to subtract the absolute value of the smaller from the larger, and we will get 4 for our answer. And we will check, and in fact, 1, 2, 3, 4 is the distance. Let's take what we've learned and find the distance between a couple of points when we don't have our coordinate system grid beside us. We're going to find the distance between the 2 points. The first thing we need to know is whether or not they are in the same quadrant. 3, 2 is in the first quadrant because both of them are positive. 3, -3 is in the positive-negative quadrant because this number is positive and this is negative, and that is quadrant 3. So we have them in different quadrants. If they are in different quadrants, then we simply add the absolute value of the 2 numbers that change. So we'll add these 2 together. 2 and -3, the absolute value is 2. The absolute value of -3 is 3, and we'll add those together, and we'll get 5, which should be the distance between 3, 2 and 3, -3. Next, we have points 1, -7, and 1, -3. Which quadrants are they in? 1, negative 7 is going to be in the positive negative coordinate, which is quadrant 3 rather, not coordinate, quadrant. And then 1, negative 3 is also in the positive negative quadrant. So we know that they will be in the same quadrant. What we have to do is subtract the two numbers that don't change. So in this one, we take the absolute value of this one and the absolute value of this one, and we subtract them. So 7 minus 3 is going to be equal to 4, and that should be the distance between those 2 points. Now pause this and work numbers 3 and 4, and I'll put up the answers. So these two are in different quadrants. We can tell very quickly by looking over here that this one is in the first quadrant, and this one is in the positive negative quadrant, which is quadrant number 3. So since they're in different quadrants, we add them together. We add the absolute value of the two that change. The y coordinate is the one that's changing. We're going to add the absolute value. The absolute value of 2 is 2. Absolute value of negative 4 is 4. And the distance is 6. These two are in the same quadrant. They're both in quadrant number 1. And so, since they're in the same quadrant, we will subtract the absolute values of the two numbers that don't change. That's going to be absolute value of 5 is 5. The absolute value of 3 is 3, leaving us with a distance of 2. Now let's use finding distance to help us find the side length of a geometric figure. In this case, we have a rectangle. What is the distance from point D to point C? We can count really quickly. 1, 2, 3, 4, 5. The distance is going to be 5. But let's go ahead and try using our coordinates. The point coordinates for D are negative 2 along the x-axis and negative 2 along the y-axis. And over here, positive 3 along the x-axis and negative 2 along the y-axis. Remember, since they are in different quadrants, we're going to add the absolute values of the two that don't change. That means we'll add negative 2, of the two that do change. And that means we're going to add negative 2 and 3, the absolute value of both of those, and we'll get 5 for the length, and that's correct. If we want to find the length of side AB, well, since this is a geometric figure, we know automatically that since the side over here is 5, this one, being a rectangle, is also 5. But we can count like we did last time and get 5, or we can do the points and see how far they are. In this case, we have negative 2, positive 4, and on this side, point B, we have positive 3, positive 4. Which are the two that change? 3 and negative 2. These two are the ones that change. Since they are in different coordinates, different quadrants, we will add them together. The absolute value of 3 is 3. The absolute value of 2 is 2. Negative 2 is 2. And we wind up with 5 again. What is the length of side BC then? What is the length of side BC? Well, this time, which coordinates are changing? It's the y coordinates that are changing. And since they are in different quadrants again, we're going to add the absolute value. So the absolute value of 4 is 4. The absolute value of negative 2 is 2. And I'll add those together and I get 6. Let's count and see if we're right. 1, 2, 3, 4, 5, 6.